the first mean value theorem isn't that difficult either. So once again, we consider a function f of x, and here we only make one requirement. We state that f of x has to be differentiable in some region from a to b. So if we assume that the function is differentiable, then there is such a value c such that the following condition holds. And the condition is as follows: f of b minus f of a is equal to b minus a times the first derivative evaluated at c. And once again, we assume that c is somewhere between a and b. And we can actually rewrite this as a kind of division, so we can have f of b minus f of a being divided by b minus a being equal to f prime of c. So what does this mean? Well, we can look at it in a geometric fashion. So if I just draw the axis lines once again, let's suppose that we have a function going something like this. Okay, so here there is no requirement for a and b to be equal, like we had in Rolle's theorem. Essentially, they can be completely different values. So for example, we can have a being somewhere here, and we can have, let's say, b being somewhere here. So let's have b here. Now what this theorem is essentially stating is that if you draw a line, so if you draw a chord from the points that are pointed to by a and b like so, then somewhere on this interval there is a tangent to the graph which is actually parallel to this chord that we've just drawn. So we can essentially draw it like this. So it's basically saying that whenever you have points A and B, there's always going to be a point which has the same incline as the chord drawn from the appropriate points.